Hi, everybody. My name is Juan Cicada, and I'm the principal scientist at Data.World.
And I'm Andreas Blumer from Pool Party Software Limited, and thanks for inviting me. I'm happy to be here. Very excited.
Andreas and I will be talking today about why a data catalog powered by a knowledge graph is a foundation of a data fabric. But let's first start with clarifying some terminology, right? Our title has a lot of, let's call it some buzzwords. Let's go kind of clarify what these means. We talk about a data catalog. A data catalog is a metadata and data management tool that helps your organization to inventory and organize the data that is within all your systems. Now, a knowledge graph is technology that enables us to go do data integration and integrate data from disparate sources. But very important is that your real world concepts and your real world relationships are first class citizens within the entire ecosystem. And this knowledge graph is represented as a graph. Therefore, your real world concepts are basically nodes in the graph, and the relationships are edges between those nodes. Now, we've been hearing this term called a data fabric. And a data fabric, we can look at what our colleagues at Gartner and Forrester are defining it. So Gartner, in one case, defines it as a single and consistent data management framework. So you can imagine it as being almost as one end-to-end solution that will be able to go manage all your data and your data integration. Forrester, you can see it adds a little bit more, adds some focus to it, saying you want to be able to go automate the integration, the transformation, preparation, curation, security, governance, orchestration, and probably other things that we're not all talking about that today. So essentially, a data fabric seems to be this end-to-end solution to be able to go do all of your entire data integration, but obviously the devil's in the details here. So our goal is to provide these three takeaways. First, a data catalog as a foundation for your data fabric. Second, we believe your data catalog should be powered by a knowledge graph. And third, your knowledge graph should also be powered by a data catalog. So let's start with that first point, the data catalog as a foundation for your data fabric. So as we mentioned, you have all your different sources that your data producers are going to be managing. There are data warehouses, the data lakes, you have old files, you have different analytic platforms, and there is this big gap. But because at the end, we want your data consumers to be able to answer their business questions using any type of self-service analytic tools, graph analytics, AI machine learning models. And this whole gap here seems to be what the data fabric should be. Now, if we look at the data fabric, all these, what are the components that are part of it? We're talking about data governance, data glossaries, data virtualizations, federation, quality, security, preparation, lineage, data, ... There's many more things that are going to come out tomorrow that we don't know that we're going to say it should be part of the data fabric. Now, realistically, our point of view is that it's really hard to have an end-to-end solution that's going to cover all of these different data boxes that we have here. Our point of view is that you really need to have a data fabric built on a very specific foundation, on actually two pillars. First, on a metadata management pillar, which is where you want to be able to do your data glossary and your data governance. And second, on a data management pillar, where I want to be able to go access my data in a virtualized manner and be able to combine data together through data federation. And these two pillars is the foundation. And that is what the data catalog is. So our point of view is that a data catalog that has metadata management and data management features, they are that foundation to go build your data fabric. Because then all these other types of data tools, data lineage, preparation, so forth, they can start interacting, connecting with your data catalog. And all together, they will make that data fabric. Andreas, I know you have a lot to say about this.
Yeah, it's a fantastic introduction. I think lots of misconceptions at the moment are around what a data fabric could be. Some people believe it's a software you can just purchase and install, and off the shelf you will get all these features baked into your platform. But this is not the case. You pointed it out really nicely. It's a journey. To build a semantic data fabric, or the data fabric, first of all, is a journey. And it's really important to see, okay, where do we have to start? So what do we have to have in place? and how important the metadata management part is to finally come to the point where you can say, oh, my data fabric can do really all those great things. This is so important. And we will come quickly to the point where we explain a little bit more in detail why the knowledge graph then is so important to deal with all these heterogeneous data sources and especially the heterogeneous metadata.
And one other aspect I'd like to touch on, Andreas, is when we think about it, a data fabric from end to end, we have all these different types of sources. And I think a lot of us within the industry, we focus a lot on those more structured sources, on the data, on your databases, your relational databases, data warehouse, lakes, and so forth. But there's also these other sorts of unstructured data that we need to be able to combine and integrate, and the data fabric should be able to put this all together. I think that's another point that we need to go make sure that we drill down on.
That's absolutely right. I think in reality, of course, there's a lot of structured data in place, but what if we could mix in all these unstructured pieces? I think this is exactly where then we can talk about transforming data into knowledge. This is exactly what we should do much better than we can currently do with the existing systems.
So our point here is your data fabric should be built on the foundation of a data catalog. And if you've heard me talk before, my mantra always is don't boil the ocean. So let's not expect that we can have an end-to-end solution that has all these different data boxes. You want to have a foundation that you can go build on and then bring in the things that you are most important for you, for your particular use case. Data quality may be much more important right now than data lineage. Later on, you want to bring in data lineage, so forth. So there's not just one silver bullet here. So the second point I want to go make is that your data catalog should be powered by a knowledge graph. Why? Well, first of all, by definition, the knowledge graph data model graph is flexible and agile. And if you compare that to traditional relational technologies, they're very schema first, they're very rigid, and they're very inflexible. So what does that mean? Is that if you're built on a foundation that enables you that flexibility and agility, you are able to accommodate any new types of sources of data. Let it be any types of new structured sources, semi-structured, you're going to crawl APIs, or as we were discussing right now, unstructured data too. I need to be able to have a model where I can go in and crawl and catalog all the types of sources. And in addition to bringing in all those different types of sources, you want to be able to interact with other types of data tools, like data quality tools, data lineage tools, and so forth. And you want to be able to bring in that information that comes from those tools and put that into your data catalog. And the knowledge graphs give you that flexibility. So what does that look like? So in reality, when we talk about the concepts here, we're talking about things like, what are the tables? What are the columns? What are the dashboards? Who are the people? Who are the data stewards? What are my business terms? And I want to start relating all these different concepts together. For example, Sarah, who is my data steward, Sarah is the person who's responsible for a particular database or for a particular set of tables. I want to be able to say that this table is derived from this other table, and that starts to represent lineage information. And as you can start bringing in all this metadata from multiple sources, it naturally fits into a graph model. And at Data.World, we actually have our own model, which we call DWEC, the Data.World Enterprise Data Catalog model. And this is built on top of all the open data standards. So we're not reinventing here the wheel. We are making use of all the existing open standards, such as DCAT and Bravo and so forth. Now, what makes this even more interesting is that once your data, your metadata, is represented as the knowledge graph, you can actually go query it. So you can go query and start asking any types of questions on top of all the metadata you want. Andreas, I know you have more to say about knowledge graphs here too.
Yeah, but this it's such a great approach what Data.World has taken here. There was this long-term vision of a semantic web around, and I think this is finally where enterprises all together can make that happen. I mean, the name Data.World already indicates enterprises no longer can live within their own bubble. They have to get connected to other enterprises, and there's no other way than using open standards. And I think this is one of the most powerful mechanisms knowledge graphs can bring in when built on top of open standards. And the data model, the underlying data model is such a powerful and expressive data model that there is virtually no such a data model you couldn't map to it. And that opens up many, many doors to do data integration in a much more agile way than before.
And as a further example, let's talk about data lineage. For example, we partner with Manta for data lineage. And what is really, really fascinating is that we can work with tools like Manta and bring in all that information, all that metadata from them and put it into our data catalog because we can represent that all as a graph. Data lineage itself is a graph, right? The nodes in the graph represents the tables, the columns, the different transformations, your dashboards, and the edges represents that something was derived from something else. And we can go into more of those details. So essentially here we're saying is that all this metadata that you are bringing in, your internal sources, any from external tools, this all is represented as a graph. That's why your data catalog should be built on top of a knowledge graph. Now let's go flip it around. What does it mean for a knowledge graph to be powered by a data catalog? What we see with our customers and with our users and with our colleagues in the industry is that the first step that we want to go through is to understand what data we have. And that's why we want to go catalog all of our metadata. I want to know what are the tables, the columns, the dashboards that I have. I want to know what are the terms, the business terms that we use, and start connecting and putting this all together. That helps me go find all the data that I may be needing. But just finding the data by itself, that's not enough because I need to go access the data. I need to go use it. So other tools that just focus on metadata management just helps you go find that data, but doesn't let you go access and use the data. That's why the next step after metadata management is the data management. You want to be able to go find the data and then going through the right governance workflows. I have authorization to be able to access and go query that data. And querying that data doesn't mean just go query one data source. It's because you need to start combining different data sources. And that's where you want to have data virtualization technologies combined with data federation. So I can take a query and go combine it with a query on Snowflake, on an on-prem Postgres database, on a spreadsheet that I uploaded. I want to be able to go access all that data together, be able to go share my work so that people can go find it. But what happens later on is that people start accessing the different data and they realize, wow, my enterprise data is a big mess. I'm talking about thousands of tables and tens of thousands of columns. And this is why data consumers can't easily understand the data. And at that moment is when you say, wow, I don't understand my data. I need to be able to add knowledge on my data. And that's where the knowledge graph comes in. But it is clear that we want to go through this, what I call this crawl, walk, and run step. Crawl, literally, let's go crawl our metadata. Walk, let's go start accessing our data, and we will start realizing that our data is inscrutable, and we need to be able to provide this layer of knowledge on top. What we start crawling is literally these application-centric databases. This is a sample of probably a lot of your systems may look like this. Imagine a data consumer trying to access that view of the data. Very, very hard. But what if you could give them a very simple, beautiful model of that data? And in this case, we're talking about the real-world concepts and the relationships, orders, customers, billing address, order line, products. You want to be able to provide this clean model, which is the knowledge graph, so the business users are able to go connect directly to it and be able to go think about the data in their own mental model. So when you start having questions, if you had to go answer this particular question on an application-centric view of the data, you're always writing these very inscrutable, complicated queries that not many people can go do, and you're really struggling to go work with IT. But what you really want to be able to go do is provide this data-centric view of your data. And that way, your queries and your questions are in terms of that mental model that is associated to the business consumers, to the business users. Andreas, I know you have a lot to say about this one too.
Yeah, I mean, what we see here is really an evolution towards, let's say, an interface, finally, which is able to understand natural language. We should also keep that in mind that the next step is that you just ask a question across different data silos you have in place, and the rest will happen in the background automatically. And it's so important to have this clean model, as you pointed out, Juan. I think this is key, because otherwise you get lost in translation. All the database engineers have done a great job to translate business logics into their own application-centric logic. We should make that also clear. But it doesn't scale. In the long run, you need a way to describe your data models based on the actual business logics. It should be based on a conceptual model. It should be understandable by the business owners. It should be understandable by the domain experts. And what's really missing in most of our applications in those days is the knowledge the domain experts could bring in to make the applications much smarter. It's not just the artificial intelligence, it's really the domain expertise, which is constantly missing when we look at the so-called smart applications.
And something that we haven't even discussed here, which deserves an entire discussion, is all the really fantastic analytics you can go do once you represent data as a knowledge graph, right? Not just doing any types of graph analytics and doing graph-centric approach queries, shortest path, centrality and things, but then you're able to go because you're adding more knowledge, you can go do inferences and reasoning and be able to go infer new information from the given information.
Like our brains do. Our brains are great with doing inferencing. Sometimes we do too much of inferencing, but that's a different story.
So to start to wrap up here, we want to go share with you an example about what are the types of things that we can go do together with what we've done with Pool Party and Data.World. Let me throw it to you, Andreas.
Yeah, but the basic idea was, okay, let's showcase what happens if you put together different sources, structured, unstructured, semi-structured, all based and glued together with a knowledge graph. In that case, we took already an existing knowledge graph and adopted that a little bit further. It's based in the HR field. It's about skills and expertise, and you can use that, for instance, to classify CVs, to classify project descriptions. You can then add in structured data, which is about, for instance, how frequently someone was working on certain projects, inferring from that how skilled the people are in that case. And then a matchmaking, a recommender engine was built on top of Data.World's knowledge graph. And you see here the resulting architecture, so to speak. So in the core, you will see, again, the knowledge graph is putting, first of all, together all the different data sources. Second, it's used then later on for the recommender services. It's used for the natural language processing, which in that case is provided by the Pool Party semantic middleware. And as a result, you get an enriched knowledge graph. So it's not just the data as it was initially, it's an enriched version and nicely structured version of all the formerly not integrated data put together into one knowledge graph. And on top of that, you can make use of so-called active metadata to, for instance, build out this semantic matchmaking tool. That was done quite quickly. That's also the good news. You can reduce development costs with that approach. You can reuse the knowledge graph for other applications. That's scalable in that sense. So again, what you see here as a result, putting those different data sets together, you can now use, and you can also try that out on the web if you like. There's a live demo where you can drill down and find the right consultants for your selected project automatically based on the recommender system. So please make use of this source. You can also download a white paper written by Data.World and Pool Party, which describes the entire semantic data fabric approach.
So for us, this is an example of how having a data fabric built by a data catalog. And here we're actually incorporating the data catalog with the Pool Party as a semantic middleware to be able to go do the cataloging and processing of unstructured data, putting this all together. And then with the power of Knowledge Graph, we can be able to not just integrate the data, but then later on provide even more powerful recommendations because of all the knowledge that we have there. So to wrap up, what is the takeaway? I think it is time to transform enterprise data integration. We have been doing the same type of data integration for the last 20 plus years. We need to go do something different, more innovative. And that's where the whole data fabric comes in. But we realize that the foundation of a data fabric should be the data catalog. The data catalog should be on those two pillars of metadata management and data management, and should have the ability to integrate with additional partners. Your data catalog should be powered by a knowledge graph, because you need to have that flexibility and agility to be able to connect to any types of data sources, structured or unstructured, any data sources that you will encounter in the future. That's why by having a data catalog powered by a knowledge graph, you're really future-proofing your catalog investment. And finally, your knowledge graph should be powered by the data catalog. The data catalog helps you go crawl all that metadata, start walking and accessing your data. And once you realize that you need to add knowledge to all that inscrutable data that you have, the knowledge graph provides that common language framework over all that data that you have within your organization. So with that, thank you very much. Andreas, thank you for your time.
Thank you. Thanks for your attention. And yeah, talk soon. Thanks, Juan.